Okay, so um, yeah, we need to talk about JavaScript, guys. So there are a few shortcomings, as you may know. Syntax is garbage. There's no operator overloading. It's I want to say it's very unstructured, and there isn't really a single way of doing things. And while that might be a good thing for most people. Oh, another thing. This video is a little bit out of scope. I know our channel is trying to switch to entrepreneurial stuff, but I'm gonna do some programming videos here and there. I'll put them in different playlists. But basically, JavaScript is just not very fun to work in. And you know, I'm working on this kind of 3D game in the browser, and okay, something's like really fucked up. Oh boy, that's new. Anyways, why is that happening? Hold on. What the fuck is happening? Anyways, I don't like that. I don't like disable syntax. It's like, okay, everything needs a const in front of it. Okay. Well, if everything needs a const, then you don't really need to describe it. So let's get rid of const. Okay. And maybe not everything is defined by const. Some things we have let. So let's just say like um, let is essentially mutable. So we could say, we could say mute. We could say mute, or we could just say like, I like this idea of soft. Say soft because it's malleable. It's not constant. But we could say soft or mute, whatever. And I don't like, these kind of, I don't know what you call these blocks, for, while, conditionals. The conditionals, they require like parentheses. I don't like that. I just don't like that. You know. And basically you cut down all these things. You replace these colons with equal signs. And you just try to make things more consistent because, a programming language should just be consistent. You get rid of these semicolons. Maybe you can get rid of the returns and just straight up do value. This is how Rust does it. And the result of all of these things in the end is you get a very nice, let me undo this. You get a very much nicer syntax like this. And this ideally is this is much more enjoyable to write in, you know, for a lot of reasons. It's more consistent. It's easier to look at, in my opinion. It's it's a little bit less code, but actually, this isn't the main reason I wanted to make my own parser, which I haven't started yet. Not really, but because there's no operator overloading, like we can't evaluate things like this, and you know what I'm saying, like dot product. And now that I'm kind of thinking about it, this is kind. I mean, this is. I mean, this could be the same as accessing a variable. This could be like B A's B. So how do we differentiate, A is B versus A dot B? But anyways, this could be wedge product. This could be, you know, vector multiplication. I don't know. I don't really know. But point is, it's definitely not right that we have to write things like like this, for example, right? Like this shouldn't be a thing, in my opinion. And and another thing is like I don't want to really write. I don't want everything to be in an array. Like I would like to just be able to unpack arguments. But I don't think that's possible to do in parse time. Like you could that's I don't think that's really possible to do. Is it? I don't know. I don't know. Like if you write do and we return A, B, let's just say we return 1, 2, and we say do, console. We say like A, B. Oh, look at that. So in JavaScript, this would look like this. Function do. This would look like this. So all you're doing at the end of the day is you're just unpacking. You're just unpacking the array. So whenever we return, whenever we do something like this, we're really just doing, yeah, I mean, whenever we're doing this, we're really just doing this. And yeah, so I mean, that should be possible, I guess. But how does it work if you inline it? Because the only thing is like this unpacking, you only know if you write it out like this. Otherwise, you don't really know. Because if we say, for example, like debug.log, you just say console.log. Like this, the parser doesn't know what this really returns, right? Does it? I don't know. No, it doesn't. It doesn't really know. Because anything can happen between here and here. Anything can happen. So you can't assume. I don't know, can you assume? I have no idea. It's all shit that we have to experiment with. But, I like this syntax much better than this. So, kind of the goal here is to get JavaScript from looking like JavaScript to looking like something more intuitive and so that we don't have shit like this. Because let me show you real quick what this came from. It's gonna blow your mind. So let's just go ahead and look for it on my entire fucking system. So we go ahead and just open this. Okay. this right here. These are the same thing. Isn't that just stupid? These two things are the same thing. And look at how much more fucking complex it is. Just because we don't have operator overloading. And to be honest with you, operator overloading is not good. Which is why we're not going to do operator overloading. We're just making a parser that expands this out from this. So here's what our parser is going to do. It's going to do everything to turn JavaScript into this syntax, and on top of that, it's going to turn this shit into, this shit. Right? And we'll replace the ads after. But basically, yeah, I mean that's it. So it's going to turn this into this. Right? I guess. It's going to do something like that. And yeah, because I'm sick of, not I want to just be able to write things like that, and I can't. So yeah. And kind of, the more code that we write, the more characters we have to write to describe something, the more error, the more head tracking, the more internal tracking we have to do, and the more things we have to be aware of, and it's just fucking annoying. So, how do we do it? You have to make an entire fucking JavaScript parser, essentially. So, I write JavaScript in a very, very simple way. Actually, we don't have to make a JavaScript parser. We have to make a ZScript parser. That's what we're calling this, ZScript. And this will convert to JavaScript. So, I mean, where do we start? Let's just see what we can figure out. I'm so tired right now. This is like totally not a good time to be doing this shit. Also, why the fuck is this broken? I mean... Oh! It's not broken. Okay, yeah. Just so fucking sensitive. This is dumb. Yeah. So we're gonna figure this out. We're gonna figure this out because I'm just look, this is broken. Why is it broken? Because I used ChatGPT to help me. And of course it's fucking up everything. But no, I want to write less of that. So, okay. This in its current state is working. This entire program is working. The goal here is to get it off of JavaScript and onto ZScript. and have this program recompile into main.html, and this should just work. And it's all, you just have an entire program that's made and it just works. So, okay. And yeah, so I don't really know what I'm doing when it comes to making parsers at all, but I think I have a good idea, a good enough idea. I think we can just regex a lot of it, you know. So let's just try. So we have this ZScript. I don't know if I should make a new branch or not. Let's just, yeah, let's make a new branch here. So I'm gonna call it I don't know. Yes. Okay, so now we're on the ZScript branch. So I'm just gonna actually move these into another script or folder. Let's make sure this is still working. Yeah. And then yeah. I'm so sick of writing this shit. Alright. So I don't know. I'm just gonna use for now. No, I don't need that. I don't need that. We can be in here. Um, do let me do that. Do that. What are we writing this in? What are we writing this? We're gonna write this in legit. Yeah, let's write in legit. Okay. So we're gonna open up the pipeline thing. So I don't know. I gotta open map pipeline.cs and read mode. This is actually not a file. This is a handle. Handle.read. You just want to read one character? How do we read one character? No, and we do this forever. We say, okay, this is a character. You know, and then we say if there's no character, then we break out of this. And you know, that I'm sorry, actually we're not even supposed to be yeah, so read file expected number. All right. So now we're reading every character. Let's kind of break down let's just say, okay, what are like the different things in here? Like we have this idea of like blocks and variables and you know values and you know how do these things kind of correlate? So you know everything at the end of the day maybe everything is a block or something. But, you know, this right here, this is like an assignment. We're saying, okay, math pipeline module is this thing. And, you know, what's described in here can be anything, essentially, infinitely complex. So, you know, even what's described here could be infinitely complex. The variable name could be infinitely long. I think the goal here is to find patterns. That way we're not making like an infinite amount of cases, obviously. So what are like the cases we can find? Okay, we have this idea of a variable assignment. And that happens here, that happens here, that happens anywhere there's an equal sign, essentially. And it's a little bit different here, I guess, because it's happening within, it's essentially happening inside of an object. So okay, how do we, you know, how do we do this nicely? I don't know. And like, what if we started out like this, for example? What if we started out like this? What if we started out like this? So we start out kind of in this limbo where, you know, you know, what is our next state, essentially? It could be an assignment. It could be a variable name. It could be a function call, technically. It could be anything. It seems to me like it could be anything. So the first step is getting from this limbo state to, you know, function call. It could be an assignment. It could be, who knows? Could it be more limbo? I don't know. I mean, this is limbo. Could be we could be like returning something. Return. I guess that wouldn't really be valid, actually, would it? Okay, well, whatever. If it is a assignment, what does that mean? Assignment? Huh. But an assignment kind of refers to not just this, it refers to this. Right? So an assignment kind of refers to, assignment is really the same thing as like variable followed by equal sign. So like it starts with the variable. So maybe instead of assignment, we should say this is variable. And variable can be succeeded by an assignment operation. And if it's not, if it's nothing, if nothing, then that means it's just like a return. So like nothing, I don't know. Right? Because if if we just say two, if we just say ASD. But here's the thing. It's not about it being a variable, it's about it being value. So value describes, value could be variable. Value could be, number. It could be object or list. Oh, we're actually just going to assume there's no list. Everything's an object. It's going to be like Lua table. It's just going to be like tables. I don't know. Value, number, object, or string. And when I say string and object, I'm referring to the explicit, what's written after it. I'm not talking about what the value of this thing can be. Because at the end of the day, the parser is aware of anything it can read. But beyond that, it doesn't know what will happen in the future, really. I don't think. Like, it's not going to run the program. So, variable. I think variable, we should just say name. We should just say, yeah, we should just say name, because this idea of a name, a human name. So value is any one of these things, right? Value is any one of these things. And should it be a name? Yeah, I don't know which way it's a function call. I don't really know. So limbo followed by function call, or followed by value, which you know is followed by a name. I don't know. This is kind of stupid. Name followed by nothing is return. A name followed by an assignment is a value. A name followed by an assignment. Yeah, I don't really know how to describe this, to be honest. It's just kind of, I don't really know what this describes. It describes like the state change. So I go from limbo to a function to potentially a function call to potentially a value to potentially a name. And potentially a nothing, potentially name, nothing. Yeah, this is making more sense. An assignment. Let's take a look at everything else. And an assignment can be to an existing variable So we have to figure out if it's being assigned to an existing variable, right? And kind of the way you have to do that is, let's say for example, we're assigning to current here. How do we know that this is not a declaration like here? Because this expands out to const. Remember, this is like we're creating a variable. But why, syntactically speaking, this is the same thing. So this should expand out to a constant, but we don't want it to because right here it's explicitly soft. So this is this should not, we should be assigning to this existing variable. So how do we do that? And I think all we got to do is, if we've gotten this far, then we basically know everything from this point and going forward. And if we see that there's a variable named current in this scope, then that means that this is not a declaration. This is an assignment to the current existing variable. So it's not stateless. We actually have to keep track of state. And that's, that might not be easy, but I think we can figure it out. Let's make sure this is... Yeah. So we're going to go through this character by character, and I think, yeah, let's just see what we can do. So, right, if character is an equal sign, then I feel like we're jumping ahead. I feel like we're not supposed to be doing this. No, but let's just say it. If character is an equal sign. Okay, well, that means we have to keep... Okay, what are we trying to find here? We're trying to find the variable name. Okay, but we need to make something that parses variable names. Okay, well, how do we know if it's a variable? How do we even know if we're in that state? And I think kind of right here, we already know that, like, we're in limbo. We start in limbo. Let's yeah. Let's assume first thing we have is a variable. So we're in the variable state. So state equals, variable. Let's say if state is equal to variable. This is really stupid now, but it's gonna get better. It's gonna develop. If state is variable, then we're just gonna say, okay, like var name is, and then var name equals this is dumb right now, but we're just gonna make it better. Var name equals var name dot c. Then I don't know if c is not equal to, if c is equal to space, that means we're no longer in variable mode. We're in like state is state is something else. And then now let's try running this. Let's see what we get. Look, we got like the math pipeline module. Okay, but like this is just stupid to read. This is just stupidly dumb reading this. So okay, this is a variable, an assignment. And I think a stack is the right data type for this. We push this onto the stack. We continue going until we have this big, I guess, tree-like structure. And I guess let's just see what that does for us. So, but okay, so when do we pop the stack? So we push, okay, we got a variable, then we got an assignment, we got, you know, the values. Let's say const, oops, state stack, make stack. No, we're just gonna make a stack. Push. I mean, we could just say, stack.pop. And then also we gotta stack.pop. Let's say return items. Yeah, I don't know. So, whoops. And then I kind of want to just print everything. Yeah, so you know, I don't know why we fucking chose away. Whatever. Just gonna fucking do it stupid way. And then also, I think we should use enter. Oops, do else do no echo do the look enter legit do. Okay. Should be 0. then this should be incrementing. Should decrement. Yeah. So and then let's just say state dot push a. So let's make it do like this. Yeah. Let's just say, how do we repeat a string? Or k equals 1 through I do I dot write. Um, See, I want it to print the depth in the stack. But I don't actually think this is, I don't think this is doing it right. Anyways, we're just going to make it print the item. And we're just going to do this. Right? Okay. So I pushed like 4 items. Okay, so the idea here is we store the state on the stack. And this is just some global state. And we just do everything from here. And I don't know, maybe should we assign things to the stack? I don't know. Do we need push and pop? I don't actually think we need push. I think we need push and pop. Just say stack is a table. You read through this. Stack.state. State equals variable. Okay. If C let's just say if alpha numeric C, then is there a way to do this? Actually, let's just say how to get if the character is alphabetical in the We're actually not just gonna, we're not gonna do alphanumeric, we're just gonna say alphabetical. Right, so just do that. So then it's alphabetical. Then I guess, you know, stack state. It's not a variable, but it could be like maybe like variable. Right. And then, you know, the thing though is like, doesn't this depend on which state we're on? So we have to start out in limbo. Stack.state is limbo, which is going from not knowing anything about what our next step is to then maybe knowing something, like deductive reasoning, because, you know, if we know this is a variable, then if we know this is an assignment, then we know there's going to be an equal sign. But we don't even know it's an assignment because we don't know it's a variable. So we have to figure out whether this is a variable. What could it be? It could be a function call. It could be like a value name. So we kind of have to figure that out. So we say, if stack state is limbo, then we can do this check. So we want to see it could be variable. Maybe we just call this name. Just call this name. Maybe it's certainly a name, actually. You know what? It's actually certainly a name. Yeah, it is certainly a name. So that means that actually values if it's a name, whoops. If it's a name, then it could be followed by an assignment. It could be followed by an invoke. Because it could be a function. It could be followed by nothing, in which it's return. And it could I think we should actually finish the assignment. So if it is an assignment, it could be followed by a number. Right? It could be followed by any one of these. If it's assignment, it could be followed by a number, an object, a string, or even another name. Which means that this sequence can like fucking recurse. It shouldn't be able to. You can't have equal. But according to this, you can. And then if it's nothing, this is just return. That means that we return, we go back. I think we go, what does it mean, like, this chain? Go from limbo to name. Let's just assume that there's an assignment. Let's just assume that we're assigning a number. That means that we have gone through the assignment, we've gone through the name, and we've gone through limbo. So this is kind of the stack, right? If we've gone down to number, if we've gone down to assign to a number, then that means we know it's an assignment, and that means we know that it's a name, which means we know the name. So basically, because we're keeping track of all this state, we should know all these things in the stack. And yeah, I guess we just kind of have to figure it out. I can't remember what they call this. I think this might be an AST tree, abstract syntax tree. This is a parse tree or token tree. I don't know what you call it. But anyways. Also, we don't want to do this if it's we break before that happens. Right? Yeah. I guess. We might want to pop after that. So if we're in limbo, if it's alphabetical, then that means we're in the name state. So we're going to make another case here. If, else if, stack.state is equal to name, then that means that the next possibility, you have a few things. This could be could it be? Could be, really it's going to be an equal sign that we're looking for. It could be an invoking thing. So we could have parentheses, we could have equal sign, right? It could be, right, invoke. It could be nothing. Let's focus on assignment. So okay, if C is this, else if C is this, then this means that basically either one of these means that I guess I don't know. I mean, this is kind of fucking, this is really interesting. Because when we change the state, we also need to append information to the stack, like variable name. So stack variable bar name is just going to be an empty string, and then here we have to say stack.bar name. This should not be stack.bar name. Sorry, this should be stack.current or something. Stack.push. Sorry, this should not be called stack. This should be called something else. It should be called state. Var name. Yeah. State.var name equals state.var name plus C. And then if we hit any of these, then that means, okay, well, if we hit this one, then that means the mode is invoke. I don't fucking know. We're just fucking state.mode equals assign. Oops, I keep doing that. 939. State.mode. State var name, state mode. Oh, I think we're fine actually. So let's print lol. Print. Let's just say this. Print invoke var name. Attempt to perform arithmetic. So we've reached an assignment. That's a good thing. State var name. Oh, state. Oops. And then, I mean, because we're changing. So here's kind of what I'm discovering. Every time we change the mode or the parser state, whatever you call it, we need to basically pass some information over. Because here we care about the var name that we've parsed. Right. because we know we finished. So, oops, I keep fucking doing that. Pipeline module. And we're fucking missing a character, which is great. If state is limbo, then we get, okay, well, if it's alphabetical, then we change the state to the name. State. Let's make like a function called like change state or something. State node. Change. And this up here. And I think we should call this next or something. Maybe. I don't like this. I think we should let's say state, okay. State dot, okay. Function state dot next. And this is just going to return the next character. And then we can have like state change to the type, and is it that we're changing, or is it that we're pushing to the stack? I think it's like we're pushing to a stack, because this is kind of like we're getting deeper and deeper into this. We're getting deeper and deeper in the stack. So we have to I think we should actually push. We'll figure that out. Let's say this for now. Let's print the type. We actually don't need to do that. Okay. Yeah, we're gonna do that. We're gonna print the type. Get single results. Change limbo. And then instead of doing this stuff, I think we should do this. And then, like, obviously this is just going to, it's not going to return something if there's nothing left. Save mode. State is forgot to do this. What? Okay, so now we have to. I want to get like the current character we're on. So I don't know. We could just call this state current. State.c. I don't know how I feel about this actually. And then this feels too, what's the word? Too internal. I feel like we shouldn't be assigning directly to this. And another thing is if we're changing to name, like, I don't know, it doesn't seem like they should have this responsibility. I think that this should be separated. So we could just say with if state, if I don't know, we'll just do this here. And we'll just say this. So with that, we can set that name. And we're still missing that character. Just his name. And another thing is like do like why would we be missing this character? Because we go from limbo to the name state. But by the time we switch to the name state, we're on the next iteration, so we fucking lose that. So we need to like do it on the same iteration. So maybe it's not right to do this way, this method where we call next on like an infinite loop. Maybe this is not the way to do it. Maybe it's let's see. How to write it first. Just see. See, I don't want to do stupid shit like this. This is not what I want to do. I want abstract syntax tree. Okay, we have character reader, Alexa, tokens, parser. Symbol parser. No. Simple Whatever. So let's just see parsing library. Doesn't hurt to read this. What is this? What the fuck is this? Okay, let's just say JavaScript. Parse simple. Actually, no. I don't think that's a good idea. Simple C parser. Yeah. It just rejects everything. Maybe that's the way to do it. That's crazy. That's actually crazy. That's the entire thing. That's crazy. That's the entire fucking thing. Let's see what Google says. Okay. I feel like we don't need it. Okay, so we have um I just realized we should not be assuming that we're in the limbo state. I don't think. I don't know. Let's just actually do this. So if whenever we change state, we we eat that character. Should we? Should we eat that character? Should we have a function called eat? Function state that eat. I don't know. I feel like we should. So, you know, okay, let's just say when we change, so when we change the state, we're going to eat the character. We're just going to say that. And eat is going to do all this handling of this, whatever this shit is. So, right, if state.name is or if state is name, then like we're gonna do this, adding to the name. We're gonna parse the name, right? And if I don't know, maybe this is just gonna handle changing the states, whereas this handles not that. I don't know. We're just fucking around. We're trying to figure it out. State.e. Changing, so we change the state. This should be in the eat. This should be in the change. And we have to call state.eat when we change. Because we're missing that first character. And also maybe it is safe to assume that we're in limbo. Who knows? So if it's alphabetical, we change a state to the name state. And all this does here is handle the changes. We're just gonna assume, we're just assuming. I have no idea if this is right or not. Yeah, so this, I mean, that's all this does. And then now we're just gonna print that. Yeah. And then now, because what's the word? Because we're consuming this character, because we're consuming this character now, it's not going to be missing anymore. And see, I literally have no idea if this is right. I'm just trying to balance this thing out. It's just getting, the way I'm seeing it is it's going to get really fucking deep if we don't move these, if we don't structure it and put things out into different functions. And maybe there is something fundamental about having changes and eats and nexts. Who knows? Right? Who knows? I don't. Yeah. And then um when we switch to, and then I think when we finish the state, we should have something called finish maybe. I don't know, because okay, how do we know when we're no longer at the name state? Then say state finish. When we finish the state, let's say type, also type should be mode, right? So if the mode, this is dumb. If we finished the name, then let's just say variable name, mode, not mode, I'm sorry. state.name, because we're just arbitrarily keeping track of this thing. There might be a better way to do it, but we're just sticking to that for now. Now we have to finish the finish thing. So whenever we change the state from one thing to another, that means that we're changing mode. I don't know what I don't know anything about parsers. I just have no idea what I'm doing. The mode. So basically, mode is going from a mode to a new mode. So this is like mode 1. Let's just say this. Local mode 0 is state.mode. And the idea here is if mode 0, no, we just say this. Yeah, if mode 0 is not mode, state.mode, if mode isn't mode 0. If the state's changed, then that means that we have to finish the state. We're going to finish mode 0, we're going to finish the previous state. And right. What, maybe we don't actually need to do that. Maybe we don't have to keep track of mode 0. We don't have to pass this in. We can just say this. States, you just get the current state name. State is name. We finish name. So this has to go before the assignment. And then we just say if mode, then we don't need to pass this in anymore. Yeah. If mode is not the new mode isn't the existing mode, then we finish the state, then we assign the new state, and then we do some bullshit here. We do whatever bullshit we want to do here. Right. And then we just eat. And to be honest, maybe we should always be eating. And look at that. I mean, we're getting something. So we're getting something. Can't argue with that. Let me get something to eat real quick. All right. All right. Nice. All right. So where were we? Okay. So I don't really know how much I agree with this. I just don't know. I'm not gonna say it's bad. I'm not gonna say it's good. It's all experimentation. But we seem to be getting something. Math pipeline module. So yeah, I mean the idea here is we go through each character. We check, like, are we in the right parsing mode? We just call that mode. Are we in limbo? Are we in a variable name? Are we in assignment? I guess you can't really be in an assignment, can you? Does that really make sense? Assignment isn't really a state, is it? Well, I guess we'll figure that out. Another thing to be considered is like does it actually make sense? Does it make sense that we can just change the state? Should we be able to change the state, or should we just be like pushing the state on a stack? Because you can kind of have assignments within assignments within assignments. Maybe that's out of the scope. Okay. So we're getting this, and then it's just not really doing anything after that. So let's print. Let's print the state, the mode, signs. Oh, we got stuck on the assignment operation. Okay, so what happens after an assignment? Well, if we're in assign, right? Else, if state is assign, then you know, else if state is assigned. Here's the thing. This isn't really right. We append it here, but if we finish next is calling 8. I don't think this is right that we have next call 8. Either that or it's not right that we have state call 8, because look at this. Oh god. Um, you know what I just realized? It's not that this is wrong, it's that no, that's not wrong. Because we need to have a space. If there is a space, it's not about the equal sign, it's about if there's a space. If there's a space, then that certainly means that we've hit the end of a variable declaration, whatever you want to call it. It certainly means that this is over. So all it means is that it's over. So that kind of means that we should finish the name state. And I don't know, maybe we have to change it to limbo. All we know is that it can't be any of these. So let's just say this. If state, it doesn't matter this order. Else if state.c is a space, then we have to change the state to something. We're going to change it to limbo. And we're not going to print every single fucking one of these. Finish name state. No, yeah, we want this. Yeah. Nice. Okay. Now the question is, look at it's including the end of line. Not the end of line, it's including an extra space. That could be wrong for a few reasons. I guess we'll figure that out in a bit. If we, okay, when we finish the assigned state, it doesn't, I don't think we'd have to do anything after we finish the assigned state. All we have to know is that it was an assignment. So I don't think we actually need to keep track of anything here. Who knows? Also, I feel like we should be storing all these state changes into a stack. That way, for example, we imagine just this for example, we parse this block. Or we parse here, then we parse this assignment, this assignment, this assignment, this assignment, this assignment. Then we pop, essentially. We pop the stack to get where we once were. And it like accumulates it just accumulates information, basically. And basically, after this point in time, we don't really need to know anything internally about here. Maybe. I guess we'll find out. So what's the next step? Let's figure out if this is being done correctly. And I know there's going to be an extra space in here. But, whoops. Yeah. Yeah. This is cool though. I mean, it's definitely getting somewhere. I can tell. Um, we don't have to really print anything with the sign. If the state is, if it's space, okay. We go to limbo. We go to invoke. Invoke. I don't fucking know. We're just gonna say like invoke begin. Say dot change. Invoke begin. Invoke begin and invoke end. The end of the invoke. It's not really like a beginning. It's more like arguments. This is more like arguments. Arguments begin. Begin args. Like, I don't fucking know. I'm just gonna call it that. Else if state is begin args, and then we have to have another one for like end args. End args. Right? Right, so we're gonna have end args. And begin args. This cannot happen. And you can't go from name to end args. You can go from name to begin args to assign to limbo, but you cannot go from name to end args. That would be an error. State is begin args. Then see, this is where it doesn't really make sense, because yeah, like it has to be a stack. That's the only way I'm saying it. And we'll figure that out. We'll get that figured out. If state stage, then we change the state to end args. Right, if we're in begin args, the next character we ate, then we change to end args. And if we change to end args for state eat is name. Yeah, so if we eat the name while we're in the name state, then we get that. Finish while we're in the name state, we get a variable name. We're just gonna do this. Also, these aren't args, these are fucking parameters. And if we're in begin params, we're just gonna append these params. If we change to begin params, we're going to reset that to an empty string. If we finish begin params, then we're just gonna print the params state.params and then params char. Is that right? Yeah, like we got a char there, char here. Yeah. Another thing is like, I feel like this is inefficient to do character by character. Because we can represent, like, we know what this is. We know that this is a red, we can regex this thing, right? This domain of characters can be represented by a regex, terminated by, the space. And then, given just that, we can kind of figure out what's going on, maybe. Another thing to note here is a name. The name state can be terminated by like an assignment or an access. I don't know what you call it, just like an access at an access, right? An access operation. State.c is equal to a dot. We get a dot, then we change the state to access. And access doesn't really need to be I don't really think it needs to be really considered. Yeah, this would be so much easier with regex. So I think what we do is we match the shortest one. Because here's the thing, right? Like, we don't want to like overmatch. Because if I'm trying to think of an example where you could overmatch. Maybe it's not possible. Yeah, I don't know. Let's just do it this way. We're gonna do it this way for now. Change it to access. Are we accessing it? Yeah, we got a bunch of axes in here. Oh, this is gonna be so annoying for if, though. Oh my god. Let's do this. Let's do this. Um, seek. Let's have a seek um function state dot seek. And then oh fuck still. And then we say how do we do that? How d- how do I seek ahead 4 characters without moving forward? I just want to view from here to 4 characters ahead. What? I feel like this is wrong. It's probably bullshitting me. Right? State.seek. And then let's not print all this other mumbo jumbo shit. Yeah, it's fucking bullshit. Fuck you. No, it's not. Ha 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 ha. It was not lying. Thought it would be. Okay. So let me just do this. Man, it's been a while. What? How do you get the length of the stream? What? Oh, that's why. Got it. Got it, got it, got it. Okay. Okay. So, um, yeah. Actually, you know what? This isn't that bad. So if we're in the limbo state, then essentially we could be introduced by okay yeah, if I don't know, state.seek if then else if blah 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 blah, state.seek or oops, then else if state.seek while then else if yeah. Print I don't know. Begin params and end params. Wait a minute. End params is the same as limbo, right? Yeah. That's so we don't need that. Uh then this doesn't even need to be called begin params. This is just called params. Because that means we're going into function parameter. So I don't know why we call. Hold in here. Alright. I'm only at 100 lines. Come on, let's get this shit going. I feel like I'm going slow. Hey, it's good. I'm going at my own pace, I guess. So, um, we don't really need to hold state for things like I don't know, like assign. I don't know. I really don't know. Let's just keep fucking around with it. So, and then seek. Math pipeline module. So if we're in limbo, we seek if. If we get if, that means the next thing has to be an expression. So state.change to an expression. Same goes for for and while, right? An expression. And is that true? An expression is pretty general, right? Because an expression can be huh. But I think maybe limbo really means expression. To be honest with you, I think limbo means expression. Because an expression can be padded by, spaces. So at the end of the day, we're trimming an expression. If expression. Yeah. まあ、違うかもしれないけど。とりあえずこれで。まあ、とりあえずこれで、とりあえずこれで、なんだろうな。I don't really like this code. Change to limbo, change to name, change to limbo. Oops. Change. Finish. Um, Rams limbo. Also, yeah, I think we should do state. Instead of state change, we should do state push. So, right, because reason for that is we want to go deeper. We don't want to change all these things because if all we're doing is changing, then we're not encoding any historical information. You want to encode everything. So we say, okay, we start at limbo, then we change to an expression. Well, how do we know we were at limbo before we don't? We lose that information essentially. So I think it's important to have that information for when we go into something and then we go out of something. Because the thing is, like, we don't know what something is until we've gone through it. Is that true? No. We know what something is, but we don't know anything about its internals. Let's just assume that there's some idea that this can, whatever this is, might be different based on what's inside of it. So there is historical significance in deciding what something should be. So this thing could be this or it could be this based on what's inside of it. And in order for us to encode that, right, and there actually is a case for this, right? It's as simply as soft and assignments, like here. Why this shouldn't be const? Why? Because there's a soft that existed before. So we need to encode historical information. And in order for that, we need to push to the state. We can't just change the state absolutely. So it's just going to be like a stack. And yeah. So let's say state push. We're just going to put these inside of there. Because I like the semantics of this. I'm not worried about this looking good or anything for now. Honestly, I don't really care. It's just make something that works. Honestly, I don't even care if it really makes sense yet. I'm just gonna make something. State. So we have state. State. Stack. State. Stack. Items. You don't need this. I don't want to call it this. I want to call it total. And this push is not pushing. Right, so we gotta make this push. I don't really know the semantics. Not the semantics. I don't really know what should happen, to be honest. If we push, what exactly are we trying to store? Um, I guess what would be particularly useful is you have the thing, the type that we're parsing, and then along with the information we gathered, right? All this information that we gathered should be encoded in there. And I think a way we could do that is we just say, let's just say we can get like a node that corresponds with each of the stack objects, each of the elements in the stack. We're gonna have a stack, right? So we're gonna have this, this, these exist in this, exists in this. And when we pop, once we're after here, we should get, if we're here, and we pop the stack, what should we get? Should we get this? No, we should get this. No, we can't get this because it hasn't finished. If we're in here, and we pop the stack, we get this. No, we don't. Actually, we don't care about popping the stack. We care about if we finish something. I don't know. I don't know, but everything has a node. I think we're just gonna have a node. So we're gonna have like a node thing. So we're gonna get the node. And then we're gonna say instead of state.name, we're gonna say node. Whoops. Node.name. Node is just going to be like a table of shit. It doesn't really matter. It doesn't have to be that. It doesn't have to be that smart. It doesn't have to be that smart, I don't think. Maybe instead of node, we should just call it current. Instead of node, let's call it node. Current. Yeah. Current gives you the current like node that you're on, essentially. And when we push that node onto the stack. And when we pop the last node. So, you know, it's going to be a little bit more complex than that. But state.push expression. Pushing. Okay. Yeah. Jesus Christ. Yeah. And current. When we push, this is going to be a mode, and then the item. I don't want to call this item. Let's call this node. We have node and mode. That's not a good idea. I think we should just call this type. Yeah. And then we can say node.type is going to be type, and then we just push the node like that. And we should return the node. And when we pop, we just nullify. Just nullify. And when we seek, it's fine. Eat, finish, state, push. Oh, when we finish, we should actually pop the state. I think. Should we pop? Should we pop? Current. State.current. I feel like I'm forgetting something. Current nodes t print t is 0. Yep. State current. When are we calling current? Eat push. Call an eat. Is getting called in. It says in push. It's getting called in push. Well, if it's in push, shouldn't it exist? Unless we're not calling. Wait, what? State push. Wait, why doesn't that work? Current nodes t -1. This is wrong. This is wrong. I don't actually think we need to do this, but we will because we're going to be accurate. We're going to be correct. Better to be correct. It works. This is going to break. Well, why doesn't this work though? Why doesn't this work? State, 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 push, push, state push type. We increment, we create the node, we set its type to the type, we insert it into the nodes list, we return the node. Okay. State push. Does this return anything? It should. Otherwise, there's bullshit. Wait, what? Why is this? Wait. That doesn't seem right. Shouldn't this be printing a table? Should I be getting like an address? Yeah, look, I'm getting an address, but am I not getting an address here? Node. Why am I not getting fucking address? What the fuck? What the fuck? I'm losing my mind. Why the fuck isn't this working? This is wrong. This is wrong. The fuck? Come on, man. Shit. Fuck off with that. Jesus Christ. Okay, fair enough. Okay, fair enough. Okay, fair enough. That makes perfect sense. When are we calling current? We're calling it eat. Oh, I just realized. This doesn't make sense anymore. State is has to be updated to state.type. No, we don't do this. We don't do this anymore. We should be doing state.type should be current type. Right. State current. So the idea is if the new type shouldn't we always finish the last state no matter what? Because yeah, I feel like we should always finish a state. This doesn't really make sense right here. This doesn't make sense either. Cannot we don't change the past. We only continue. We only continue forth. We don't change the past. We don't change things. So then state is should say if the current type is given as type. Okay. And I want this in front. If the type is yeah. Right. Yeah. So if okay, and then state, where do we assign things to the state? What do we call state? Not is, not eat. Okay, params and name, those are bad. We're not supposed to be doing that. Name and params, yeah, we can't do this. It should be state.current. Name. Yeah. State current. And let's just say this is node. Can we just make this a global fucking variable? And then here, we will just make this a global variable. When we push node becomes that. My God. Yeah. Whatever. It's not that good, but you just gotta believe in yourself. You gotta believe. Just gotta believe in yourself. Is and then I don't know, like you don't really need to do this, I guess. Hold on, isn't anyone? Yeah, I mean, that should be the case. Considering we're pushing the state here, so I mean, it should be defined. Node should be defined. No way. Okay, I thought that was fucking always wrong. No, we don't really gotta do this, I guess, because these are global now. Motherfucker, is this gonna fucking do this? Dude, why is this happening actually? This should be this should just be right here, no dot type. What? How? What? Am I delusional or something? What am I on right now? Okay, that's working. What the fuck is happening? Okay. Oh God. Guys, what am I doing? I forgot to incorporate it into our big cool function that does everything. Okay. All right. So I don't think we need change. Did we already get rid of change? Yeah. So we got rid of change, right? Because we don't need to change because all we got to do is push. So, and if we're not changing, that means we don't need to check the changes. So that makes sense. This just makes sense. Like that's just a side effect. We don't need to check changes because we're just pushing. Okay, now it's pushing, so we can put that off our to-do list. So, all right. Should we finish? We will print the name. Should we do params? Should we do assign? And we're never popping the state. Okay, I think I understand now. So when finish is like pop, I think. Yeah. So we're never calling finish now. When were we calling finish? We're calling it when we changed the state. But now push will always finish the last state. If there was no state before, then it can't, but so I think all we gotta do is just say this. We just say it. And is finish push. Finish. Is finish push. Um I don't think we can finish if there is no node. Because that means that we haven't even been that means that we haven't begun still. Yeah, you can't. If node, then we can finish the state. Otherwise we can't. No value. Save finish. Where is this? Finish. On 47. Yeah, I guess we're doing something really wrong. It's doing something really no problems. This is actually wrong. Okay. So is not working because we're probably not tracking the current node. Okay, we are. We push the node, then we fucking set that as the current node. Blah 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 bullshit. Uh, Also, I feel like that should be in. I feel like that should be a node. Oh my god, this is hard. We're making progress, so I know, like, we're almost fucking there. We're almost there. Fuck. And another thing is like, okay, this entire thing, we pop all the way down to Like, that's what I don't understand. This whole pushing and popping. We get deeper and deeper into the structure to where we have this assignment is this thing that we recursively go into. Is it recursive? Then when we finish this, we pop this value, which basically compiles this entire thing. And we then at that point we know what the value of this operator is. So yeah, who knows? I think I'm working on this too much. So I should sleep for like a few minutes. And we'll come back to it. I think we'll come back to it. I'm tired.